the dura is attached especially at the sutural level, and the dura is something like a trampoline in that there are little springs attached all the way around. Then there are particularly potentially active areas of dural attachment, such as the clinoid process and a variety of other areas. And then that dura comes up in a fault device, something like that, which has then a gutter running down the center of it, the so-called sagittal sinus. And it's a system by which the brain, which rests in a waterbed, the spinal fluid, supports about 20 or 30% of the weight of the brain. And then the brain itself is separated by the falx into the two cerebri. And then there's a reciprocal tension membrane that you see here, which acts to sort of balance the two cerebelli. And as a result, the word reciprocal tension membrane is a word that literally implies that there is a tension within there. Now, that reciprocal tension membrane depends upon a variety of physiological components. There's a very fine article on the choroid plexus in the November issue of the Scientific American with some excellent drawings and some very fine descriptions of what the CSF does, what the choroid plexi do, and the difference between adult choroid plexi and fetal choroid plexi. And I think it's one of the best articles I've seen on the choroid plexus, as well as what the cerebrospinal fluid does. One of the interesting things about the cerebrospinal fluid is that it is, in addition to all the other things it contains, it also contains large amounts of carbonic acid anhydrase, an enzyme which is zinc dependent. And just as carbonic acid anhydrase, a zinc dependent enzyme, allows an easy exchange of oxygen and carbon dioxide, so also does it allow easy exchanges in the CSF. If, for example, you dissolve oxygen in water, it dissolves in about the same rate as it dissolves out. If you dissolve oxygen in blood, it dissolves in about the same rate as it dissolves out. If you dissolve carbon dioxide in water, it dissolves in at the same rate as it dissolves out. But if you dissolve carbon dioxide in blood, it dissolves out 500 times faster than it dissolves in, because of the action of an enzyme called carbonic acid anhydrase, which is a zinc-dependent enzyme. And there's a great deal of that in spinal fluid, and we'll try to enlarge upon that concept as we go along. But I've never seen an article as well done and as simply written, yet beautifully illustrated, as the November issue of the Scientific American on the choroid plexi. But there's always more spinal fluid being produced and being eliminated. It's just as if you had a salivary gland concept in your mouth, and it's just if you closed off your throat and closed off your lips in such a way that the fluid would start to build up. And then finally, when it would stretch your cheeks to a certain point, you could turn off the flow of the salivary material, which would then gradually let you swallow or possibly expectorate the accumulated saliva. The CSF is always being produced, and there's always a pressure. And as you know, if you do a spinal tap, the